Hello students, today we're going to learn P6, complex numbers. A complex number is when you have a real number and an imaginary number. So they usually write the real numbers first and the imaginary numbers last. Imaginary number is noted as I. And this is what we call standard form. Real number, then imaginary number. Alright, example 1 says simplify in standard form. So let us do example 1 part A. So what we're going to do here is we're going to distribute this negative. So when we distribute the negative, this is now positive 2, negative 9. Whenever you have a negative in front of the parentheses, everything in the parentheses becomes the opposite. Opposite of a negative is a positive, opposite of a positive is a negative. From there we combine like terms. So we'll put 2, and remember the square root of a negative is I. So whenever you have a negative inside the radical, when you take it out, it's an I. So the square root of 9 is 3. Now we have negative 3i. So we brought all the numbers down. Combine like terms. We have 2 plus the square root of 5. Negative 3i and negative 3i is negative 6i. Alright. Part B. Whenever you have a plus sign in front of the parentheses, everything stays the same. Nothing changes. So we bring everything out of the parentheses, combine like terms. Real numbers first, 2 and 3 is 5. Negative 3i, negative 4i is negative 7i. So we simplified and put it in standard form. Part C. Now there's nothing in between the parentheses, so we are going to FOIL. So distribute 2 times 1 times 3i, 2 plus 6i. Distribute negative I. So when you distribute a negative, remember, it becomes the opposite. Negative I times 1 is negative I. Negative I times positive 3i is negative 3i squared. I squared is equivalent to negative 1. Okay, so I squared is equivalent to negative 1. Negative 3 times negative 1 is positive 3. Bring down all the numbers. Now let's add like terms. So here's a real number, here's a real number. 2 and 3 is 5. 6i minus 1i is 5i. So here is the answer in standard form. 5 plus 5i. Part D. Again, there's nothing in between the two parentheses, so we're going to have to multiply. But I want to simplify this radical first. This is the square root of negative 4. Remember, whenever you have a negative inside the square root, you take it outside and it becomes I. So this is now I radical 4. And the square root of 4 is 2. So the square root of 4 is 2. So all of this is now 2i. Square root of a negative is I. Square root of 4 is 2. So we have 2i plus I times the quantity 6 minus 5i. Combine this first. 2i plus I is 3i. 3i, now we just distribute. 3i times 6, 18i. 3i times negative 5i is negative 15i squared. But remember, I squared is negative 1. So negative 15 times negative 1 is positive 15. This is not in standard form yet. Real numbers go first, so 15 plus 18i. So that is example 1. Example 2, part A. It says find the product of the complex numbers and its conjugate. Whenever you see the word conjugate, that means you're just switching the middle sign between the real number and the imaginary number. So the sign here is negative. The conjugate is going to be positive. These are not opposites because if you notice 5 is still 5. We didn't change it. So conjugate, you're just changing this middle sign to its opposite. So if it says find product, the word product means to multiply. So we're going to take 5 minus 6i times the quantity 5 plus 6i. We distribute everything. This is 25 plus 30i minus 30i minus 36i squared. So this is now I squared is negative 1. Negative 1 times negative 36 is positive 36. Bring down all the numbers. Combine like terms. So here are real numbers, 25 and 36. And let's see, 25 and 36 is 61. 30i minus 30i is 0. Example 3. It says write in standard form. So when you say write in standard form, no complex numbers in the denominator. So we have 2 plus I over 3 minus I. We cannot have any complex numbers in the denominator. So what you have to do here is we have to rationalize the denominator, meaning there has to be a real number in the denominator. So what you're going to do is multiply by the conjugate. Because if you notice, when you multiply by the conjugate here, our result was just a real number. So that's why here you want to multiply by the conjugate. The conjugate of 3 minus I is 3 plus I. Whatever you do in the denominator, you do in the numerator. Because this number over itself is equal to 1. We are not changing the value of the problem. So we just carry out the multiplication. I would just do 1 at a time, meaning let's do the denominator first. 3 minus I times 3 plus I is 3 squared minus I squared. This is from Algebra 1, where you took the sum times the difference, and the result was a squared minus b squared. That's how we got that. So 3 squared minus I squared, that's 9. We said I squared was negative 1. So minus a negative 1, so the denominator is 10. That's the first thing you want to do. Simplify the denominator. Now we don't have any more complex numbers in the denominator. Let's do the numerator now. So the quantity 2 plus I times 3 plus I is this here. This is 6 plus 2i plus 3i plus I squared. That's what happens when we multiply everything. We know I squared is equivalent to negative 1. So I squared is equivalent to negative 1. Combine like terms, 6 minus 1 is 5 plus 5i. So now we could reduce this one more time. Factor out a 5. 5 times quantity 1 plus I is still this. 5 over 10 reduces to 1 over 2. So there's our final answer. We wrote this expression in standard form, meaning there are no complex numbers in the denominator. All right, example 4 wants us to solve, use the quadratic formula. So to use the quadratic formula, first you have to make sure one side of the equation is equal to 0. So we're going to subtract 5x, add 8. Subtract 5x, add 8. Now we have 2x squared plus 4x plus 19 equals 0. This is not factorable. That's why you have to use the quadratic formula. Here's the quadratic formula. Label your a, b, and c. A is 1, b is negative 4, c is 19. Substitute these values into the quadratic formula. And I know all of you guys have done this before, so after substituting all the a, b, and c into the quadratic formula, simplify your answer. Remember, when you have a negative in the radical, when you take it out, it becomes imaginary. So now this is 60. The square root of 60 is 4 times 15. The square root of 4 is 2. So here's your answer. X equals 4 plus or minus 2y square root of 15 over 2. We could separate this into two fractions. So this is a minus also. So there's two possible solutions. X equals 2 plus or minus I square root of 15. These 2's reduce, 4 reduces. All right, that's it. Have a good day.